Next, we're going to look at number 7 from section 3.3 in your book. And this one is about the SPF of sunscreen. And one of the authors in the textbook wanted to find out whether the SPF of sunscreens used by the students at her school exceeds the recommended 30 on average. So the author surveyed students in her stat class and found that in a sample of 48 students, the mean or average SPF was 35.29, and the standard deviation of SPF was 17.19. And it tells us the data were not strongly skewed. We'll come back to that. So we're going to find and interpret a 95% confidence interval for the parameter of interest. So here we were not so lucky to have it all written out for us, so we could just copy it down when we make our interpretation. And then we have another question that we'll come back to in a minute. So let's actually think about the observational units, the variable, and the variable type. And again, I strongly encourage you to pause the video and try to write these down for yourself. These are things that you hopefully can do at this point, and you should try it out and then come back and see if you were correct. So the observational units would be the 48 students that she surveyed. And the variable is the SPF that the student uses. Notice it's not average SPF, it's just plain SPF. And of course, that is a quantitative variable. So the statistic that we're going to be interested in is X bar when our variable is quantitative. And in this case, we're told that is the sample average 35.29 SPF. We also have the sample standard deviation S is 17.19, and the sample size N is 48. And our parameter of interest, when our variable is quantitative, would be mu, and that is the average or mean SPF used by all students at the school. So once again, the parameter is about the entire population, and the question the author was asking was about students at her school. So she's interested in learning about all students at her school, but she just took a sample of 48 students in her class. So the statistic X bar is the average SPF for just the sample of students that she surveyed. Mu, the parameter, is the average SPF for all the students at the school. All right, so to come up with the 95% confidence interval, again, if you look back up for now a quantitative variable, we're going to take our statistic, X bar, plus or minus, multiplier 2 for 95% confidence, so we're using the 2SD method, times S, the sample standard deviation, over the square root of n, the sample size. So in this case, we're taking the statistic sample mean 35.29 plus or minus 2 times the sample standard deviation 17.19 over the square root of the sample size 48. So this is in the form statistic plus or minus multiplier times SE. So that 17.19 over the square root of 48 would be the standard deviation of a null distribution if we were to create one. So again, I would invite you and encourage you strongly to pause the video and do these calculations for yourself. First, the 17.19 over the square root of 48. And if you put that in your calculator, you should get 2.481, and then you can multiply that by 2 in the next step, and that should give you 4.962. So now the confidence interval is in the form statistic plus or minus margin of error. So the margin of error is the 4.962. Then we have to work with the plus or minus, so we're going to separately calculate 35.29 minus 4.962, and then 35.29 plus 4.962. And again, you should do these calculations for yourself. And when you do the subtraction, you should get 30.328. And when you do the addition, you should get 40.252. And that gives the 95% confidence interval. Next thing is to interpret the interval. So we're going to have a sentence similar to the previous two that we did. We start with, we are blank percent confident, in this case, sorry. Stop. Stop. Come here. Stop. Enough. Stop. Come up on the couch. Stop. Sorry about that. We are 95% confident. And here's where... Stop! Stop. Here's where figuring out what the parameter of interest was important, because now we want to write that down, because that again is what we are estimating with our confidence interval. We are estimating plausible values for the parameter. So we are 95% confident that the average SPF used by all students at the school. So again, this interval is about the all and not the small. It's not about the sample, it's about the whole population. And then we say is between, and we put in our numbers, 30.3 and 40.3. Now you might say to yourself, stop! Come here. Up here. Let's go. Get up here. Do not go over there. Stop barking. Gosh, I'm really sorry. So you might be asking, why are we using decimal numbers here when SPFs only come as whole numbers? And that's true, but remember, these are estimates for the average for all students. So the average could certainly come out to have one or more decimal places in it. All right, now let's go to the theory-based. So let's do it in the right order this time. Are the conditions met for a theory-based approach? And if you look back at what those conditions were, either we have to know the sample data was symmetric, or we have to have at least 20 observations and no strong skew in the sample. So in order to know the distribution of the sample data, we would have to have the actual data, and we don't have that. We were only given the summary statistics. But we were told the data were not strongly skewed, and we have a sample size bigger than 20. So we can say yes. Sample size is bigger than 20. And we were told no strong skew in the data. Okay, so knowing that it's okay to use a theory-based method, let's go to the applet. So this time we have to use the scenario drop box and change it to one mean because our variable is quantitative. And notice that it is keeping the sample size at 118 until I tell it differently. So this sample size was 48. And we have to put in the sample mean, which was 35.29. And we have to put in the sample standard deviation, which was 17.19. So we can do a calculation there. The graph is not really very helpful, but when we hit calculate on the left, it automatically creates the confidence interval as well. And again, the 95% is the default. If you wanted to find a 99% confidence interval or a 90% confidence interval, you could change that. And it's giving us an interval from 30.2985 up to 40.2815. So the theory-based confidence interval is 30.2985 up to 40.2815. And notice, again, that's very similar to what we got with the 2SD method, and the reason why they're similar is because we met the validity conditions to use the theory-based method, and so it's appropriate and gives us a valid answer. Now there was another question here at the end. It says, assuming the teacher has a representative sample based on the confidence interval, is the average SPF of students at the school higher than 30? Explain. So we could say here the average is higher than 30 because the entire confidence interval is above 30. So keep in mind this confidence interval from 30.3 up to 40.3 is a set of plausible values for mu, the population mean. And the lowest plausible value for the population mean is 30.3, which is not a lot above 30, but it is above 30. So we could say, based on the confidence interval, that the average for the entire school is bigger than 30. It's somewhere between 30.3 and 40.3. So even at its lowest, it's higher than 30.